Hi, I'm Steve Sloan, and welcome to my session at SAS Global Forum 2021. It's virtual, and I'm glad you're all here to see the presentation. I'm going to talk about 20 ways to run your SAS program faster and use less space. I'm a data science senior principal at Accenture, where I've been for 15 years, and I lead multifunctional projects. I've presented at over 20 SAS events, and I've been published in professional journals. I have a BA from Brandeis, 2 MS degrees, one in math, one in computer science from Northern Illinois University. I have an MBA from Stern Business School at New York University, and I have a graduate certificate in financial analytics from Stevens Institute. I do like to keep on learning because SAS is very good at keeping up, and there are a lot of new things coming out on a regular basis, and SAS produces a lot of new products. And what we'll be talking about today has to do with existing SAS products and how we can get them to be more efficient, to take less time and occupy less space. It can take a long time for our programs to run. The data being used by the programs can occupy a lot of space. In fact, sometimes you get in a situation where you just don't have enough space. You might have to truncate what you're doing. You might have to go through some gyrations of moving things in and out of storage. You might even have to put in a request for more memory, another server, another Windows machine. And that can be expensive, and it can slow down your progress. So what you really need, so you really want to use as little space as possible while still getting all your work done. And we can often be in a hurry. You know, we've inherited someone else's code. Sometimes we need to make a simple change to a complex program. I mean, we've always been there. Something that looks very routine, the client comes to us, and we have to really do a lot to manipulate things and change them around in order to get the program to run. Now, sometimes it works to our benefit. The client might think it's complicated, it turns out to be very simple. And we're usually under some fairly tight deadlines. So if the program runs for a long time, it can cause us to miss a deadline. It can require a lot more sitting and waiting time, and it can even interfere with other jobs that are running. They're trying to run at the same time and slow down the whole job stream, where it might not get done on time. So it's really important that for our programs to run, that we use as little time and as little space as possible, but still get them to run accurately. Now, there are a couple different types of efficiency improvements. We can use fewer observations and variables. We can reduce the number of times the data is processed. There are a lot of sorting efficiencies that we can use, and we can reduce the size of the variables. And all of these things can contribute, and when we contribute to all these things together, then we get programs that can really run more efficiently. And on a personal basis, it can definitely help our careers. We can get things done more quickly. We can be more efficient and use fewer resources. Now, if we want to reduce the number of observations and variables, we can use the drop command, the keep command. We can use drop equals and keep equals, which are data set level parameters. And in that way, we'll make sure that only needed variables are used. This can help in a number of areas. It can reduce the amount of space being used. If the data sets are smaller and more compact, then having fewer variables will mean that it will run more quickly. And also, if we have variables that we've forgotten about that we don't need, they could interfere in the future. Now, this is for the variables. For the reducing the number of observations or the number of records, we can use the subsetting if, where we say if A equals B or semicolon, and it'll drop everything else. And we can use the where statement to make sure that only needed variables and that only needed observations are used. In that way, we won't be dragging around things that we don't need and that could interfere in the future. Now, we can use drop equals and keep equals and where equals on output data sets from procs. And in this way, it'll save us time because then we don't have to go back in and run a data step just to reduce the number of observations and variables. And we may need them in the data set in the future. But if we only need a smaller amount on the proc, then we can use these commands and we can make sure that there are fewer coming in the first place without going through the extra step. And we can also use this on the output from the procs. We may need all the input, but we may need less on the output. One of the things that I almost always do when I'm running a proc summary on the output is get rid of the undertype underscore variable, which summary produces, which is useful if you're parsing a data set where you've had multiple variables in the class statement. At the same time, I often don't need the underscore freak underscore variable, and I drop that with the drop equals on the output. Now, if you don't need an output data set at all, for example, you might be doing a call synput, you might be reading from one external file and writing to another file, and you just may not need an output data set. So SAS has the data underscore null underscore that lets you do a lot of processing, setting macro variables with symput and symget, and also moving data from one external file to another. So all these are good ways to reduce the observations and variables, and that keeps your data set more compact. It's more efficient on space and will help things run more quickly if there's less being dragged around. We also want to reduce the number of times that the data is processed. In the set or the merge statements, we can use rename equals. And if you have to rename a variable to another variable, you don't want to have to go through a whole nother data set just to do that. So you use the rename equals right on the set or the merge statement, and it'll rename the variable that in the data set that you're bringing in. That can be especially valuable in the merge statements where you want to merge by a single variable, but the variable has different names in different data sets. And so if you use the rename equals, it'll take care of it right there. And you won't have to go through another data step only to rename the variable. And you might need to rename it back also later in a different data step. And you're avoiding that. You use the proc format with the control in, or you can use if, then, else, or case constructs. And if you use the proc format with the control in, you can set your own format. So suppose you have a code and you have text that goes with the code. And you're bringing in a data set with, say, 1 million observations. And they only have the code. Now, you don't want to have to sort that and then merge it with your lookup data set and just to bring in the text value that goes with the code. So what you do is you set up a proc format on your lookup data set where the format is being defined so that you automatically translate the code to the text. And then you can use the put statement or the format statement to actually make the conversion. In addition to saving you the sort of a large data set, which will take time, and the space used by the proc sort, it's also very efficient. It does a binary lookup. You can also use if, then, else, or case constructs. Again, if it's a small number where we've only got a few variables and you've only got a few values in those variables, it can be quick with if, then, else, or case. It's not the best way to program because you'll have to keep updating your code, but it works and it can be done a lot more quickly than a sort and a merge. You can also use proc append instead of set to concatenate SAS data sets. If the SAS data sets have the same variable names and you want to concatenate them, if you use the set, you're reading both data sets into the buffer to create the new one. If you use append, you're not reading the base equals data set in, you're only reading the other data set in. And so that way you're saving yourself a lot of time, especially if one of your data sets is long. You would use that as the base data set, and that would be the longer data set, and so you're only writing out the shorter data set. That can save a lot of time. Now, you can use class statements with proc summary or means with unsorted data. And that saves you the problem of having to sort the data before going into the proc summary or the proc means. This can save a lot of time. And so if you have class X, then it automatically splits up the data by X without you having to sort it. You also want to put the most commonly occurring situations first if you have an if-then-else or a case construct. As in most programming languages, a key point is to know your data. Because if you have if-then-else, and if you have a series of else statements, it will stop after it finds a hit. So if you put the most common occurrence first, then in the most common cases, it won't go through the other else statements. And the same thing in the case construct. So if you know your data well and you're using if, then, else, or case, always do it in descending order of how often they occur, and that'll save you a lot of time when you're running the program. There's a lot we can do with sorting efficiencies to make our programs run more quickly and take up less space. There's a very useful option in proc sort called the tag sort option, and it's very helpful with large data sets. It could make the program run longer. What the tag sort option does is it only brings into the buffer for sorting those variables that you're actually sorting by. Normally, proc sort will bring the whole data set into the buffer, and that'll require a lot of sort workspace. With tag sort, you're only bringing in the variables in your by statement, and from there on, it only sorts those, and then it pulls the rest in after they're sorted. Now, it definitely uses less space. It might take longer because you're making two passes at the data, one to bring the by variables in, and one to bring the rest of the variables in. However, since it's running the sort a lot more efficiently, it might even take less time. Now, you can use by statements. If the data is already sorted, then you can use the by statements with sorted data, and you won't have to use proc sort. Now, going back to the previous mention that I made of the class statement, you use the class statement with the proc summary or the means with unsorted data. That means you don't have to sort it. However, if the data is sorted, then you want to use the by statement in the summary or the means or any other proc, or even a data step where you're doing a first dot and last dot, because you don't have to use the proc sort. So in descending order, the most efficient way to run a proc with a by statement is to have it already sorted and then use the by statement. The next most efficient way, if it's not sorted, is to use the class statement. The class statement is less efficient than the by statement because it's bringing everything into the buffer and then splitting it up, whereas the by statement only brings it into the buffer in the groups. However, it's more efficient than using the proc sort and then using the by statement. And you can use the pre-sorted option with proc sort, and that'll check if the data set might have been sorted, and if it has been sorted, then it won't run the sort. I wouldn't use that all the time, though, because if you know it's been sorted, then the pre-sorted is an extra step that you wouldn't need to take. So use the pre-sorted with the proc sort if you're not sure if the data has been sorted. It's an extra check, so if you're sure it hasn't been sorted, just go ahead and use the proc sort. Okay, we can reduce the size of the variables. You can use the length command to define the lengths of both character and numeric variables. If a numeric variable is always an integer, we can use the table at the end of the deck to define the length, and I'll be showing you the table later. You can calculate the maximum length of character variables by taking the length of each variable and seeing what the maximum is after running it through a proc means or a proc summary. The variables coming in from Oracle or Excel, they sometimes default very long, 250 bytes often, 1,000 bytes, and you don't really need that, and you can save a lot of space by reducing their length. Now, you can take an integer numeric variable and switch it to character if it's between -9 and 99, because as that chart in the back shows, if you the smallest numeric variable you can have is 3 bytes. So if it's less than that, you can go to character variable. Now -9 is the smallest you can get on the negative side because the minus takes up space in a character variable. Now we can also change all integer character variables to numeric if they're longer than 3 bytes. As you'll see, if you have a character variable that is all numeric and that it might go from 0 to 999,999, that's going to be 6 bytes, but you only need 4 bytes as a numeric variable. And you can check if it's numeric by using the int function to truncate, and then make sure that, you can check if it's an integer by using the int function to truncate, and then make sure that the truncated value is the same as the integer. And you can check if it's numeric on the character side by using the input function, making sure you don't get any missing values. There's some other efficiencies. You can use reuse equals yes, and change compress to yes or binary. Changing the compression might make the job run longer because you're compressing and decompressing, but it really speeds things up. And reuse equals yes saves space, because what will happen there is that SAS will not normally go back to space it's already used. However, with reuse equals yes, it'll go back to space it doesn't need anymore, so its overall footprint will be smaller during the program. Now, compress equals yes gets rid of repeating characters, especially useful if you've got a lot of blanks at the end. And compress equals binary doesn't respect the byte boundaries. It just squeezes them in as closely as possible. I've had reductions of space of over 90% using compress equals binary. Again, it depends on your data. Even if you've shortened as much as possible, you still might have variables not using all the space that you've defined, and so the compression will really help. Now, SAS will delete all of the work data sets at the end of the program, but if you're sure you're not going to need them anymore, you should proc delete or proc data sets and delete the work SAS data sets as soon as you don't need them, and then there'll be less space, especially when combined with reuse equals yes. And when extracting from external databases like Oracle, do as much work as possible in the external database. You use the connect instead of the live name. If you use the connect, all of the work is going on in Oracle, for example, or Sybase, Teradata, and then you're only bringing back to SAS what you've needed after processing. So there's much less time going over the pipes, and you're using efficiencies that are built into those external database systems. It could require more processing once in SAS because you don't have the SAS functions available in Oracle, for example, whereas if you use the live name, you're using the SAS functions. In my experience, though, what you save from doing the work in the external database by using the connect piece, it saves you much more than you lose with the extra processing that you might need. Could be an interesting topic for a future paper to see exactly where the cutoff is and perhaps make this efficiency number 21. Here's what I mentioned earlier about computing the length of numeric variables. So you can see, for example, if your largest integer has an absolute value less than or equal to 8192, then you only need a length of 3. Likewise, the example I gave earlier, if you have a character variable that's all numeric, that goes up to 6 bytes, that won't get higher than 1,000,000, you'll only need a length of 4. So there's some real savings as you go back, as you reduce the size of your numeric variables, and even going back and forth between character and numeric. Thank you for paying attention and for listening to my presentation. I really enjoy giving them, and I really like to get to know people. My contact information is here, so please reach out to me if you have any questions. And if you have any suggestions, we could expand this perhaps in the future to have more than 20 efficiencies, do a little crowdsourcing, and I'll make sure to cite your contribution the next time I deliver this paper. So thanks again for attending, and I enjoyed giving the presentation.